Hello everyone, I'm Sanjay Vasu and I'm back again for another video. This time it'll be the Cambridge IGCSE and Maths Paper 2 Specimen Paper 4 exams from 2025. You're allowed to use a calculator. I'll be doing questions 9 to 12 in this video. Let's start. Question 9. The diagram shows a rectangle ABCD and an arc AXB of a circle with center O, the midpoint of DC. The length of BC is 8 centimeters and length of DC is 30 centimeters. Angle AOB is theta radians. A. Find the perimeter of this whole shape ADOCBX. Well, the perimeter of the shape is going to be this plus this plus this plus this arc here. So we know three of the sides already. This is 8 centimeters and we have 30 centimeters, 8 centimeters. So the only challenge will be finding this arc length. Well, what is the arc length formula? That's theta times r, where r is the radius of the circle and theta is the angle in radians. Well, how do we find theta and how do we find r? Firstly, finding r is easy. We can find the length of OC. Because O is the midpoint of DC, OC will be DC divided by 2. So 30 by 2, which is 15 centimeters. So once you've got 15 centimeters here, we know that this is a right angle triangle, triangle OCB. So we can use Pythagoras theorem to find OB. OB squared is equal to OC squared plus BC squared. And that means OB is equal to the square root of OC squared plus BC squared, which is 15 squared plus 8 squared. Now this turns out to be 17 centimeters. So we found the radius, which is 17 centimeters. And that's OB, and that's also equal to OA, because it's the same thing. It's also another radius. So now we found the length of OB and OA. I'm using these tick marks to show that they're equal length. Now how do we find this angle? Well, there are two ways to do that. Number one is to find this angle here, because that's the same as this angle here, and then we can do 180 minus both of these to get the theta angle. The second way is, because we know this side length 30, and then we know that both of these are 17 centimeters, we can use the cosine rule to find this angle. I shall be using the way by finding this angle and this one, but you can use cosine rule as well. Let's find the angle BOC, that's what we want. So we can see we know all three of the side lengths for this triangle, so we can use any trigonometric function. Here I will be using the tangent, which is the opposite divided by the adjacent. So angle BOC will be the tan inverse of the opposite by adjacent, or 8 by 15. And we can do this on our calculator. Let's change the mode to radians first, and then 8 divided by 15, which is equal to 0.533. And then tan inverse of this is 0.49 radians. Now this is also the same as angle AOD, which is this one here. So these two are both 0.49 radians. And 180 degrees, which is this whole angle here, is pi radians. So this angle theta is going to be pi minus 2 times 0.49. And when we do that, pi minus 0.98 basically, 2.16 radians. Well, now we can find the arc length. So the arc AXB length is going to be theta r, which is 2.16 times r, which is 17. And we just multiply this by 17 here to get 36.7 centimeters. Now we can find the whole perimeter. So the perimeter is going to be 36.7 plus 8 here, plus 8 here, plus 30. And when we do that, we get 82.7 centimeters, 3 significant figures. That's our answer. Let's go to part B. Find the area of the shape ADOCBX. Firstly, we can find the area of the sector quite easily. It's just half theta r squared, and we already know what theta and r from the previous question. Now we need to add the area of these two triangles. Well, they both are congruent triangles. They're the same lengths on all three sides, so using SSS property, they are congruent. Therefore, we can just multiply the area of the triangles by 2, because we have two triangles which are basically the same, so the area will be the same. That's why we're multiplying by 2. Now we can just substitute the values. Half times 2.16 times 17 squared plus 2 times half will be 1, so we just used base times height, so 15 times 8. And let's just do this on our calculator. 17 squared is going to be 289, and then times 2.16, and then divide by 2. 312.12 plus 15 times 8, that's plus 120, to get 432.12 centimeters squared. That is our final answer. Let's go to question 10a. In the expansion of 2k minus x by k the whole to the power 5, while k is a constant, the coefficient of x squared is 160. Find the value of k. Well, firstly, we need to know that we can use the binomial theorem, which I have just displayed here. This is found in the first page of the paper. There is a small formula sheet where there's some essential formulas like binomial theorem given there. And you will see this exactly given there. So this is something we can use for this question. So we can see over here that a is equal to 2k, b is equal to minus x by k, and n is equal to 5. Let's just write that. A is 2k, this is b, and this is n. Now the coefficient of the x squared term is 160, and the x squared term is where b squared occurs, because that will become x squared by k squared. And the b squared term is n choose 2, a to the power n minus 2, b to the power of 2. So what is n choose 2? That's 5 choose 2. That's 5 factorial divided by 3 factorial times 2 factorial. So that's going to be 10. Now a to the power of n minus 2 is just going to be 2k to the power of 3. 2k whole to the power of 3. That's 8k cubed. Now what's b squared? Of course, that's going to be minus x by k the whole squared. But negative squared is always positive, so we can write this as x squared by k squared. Now we just have to multiply this to get the second degree term. 10 times 8k cubed times x squared by k squared is going to be equal to 80k x squared. Now the coefficient is equal to 80k, and this 80k is going to be equal to 160 based on what's given in the question. The coefficient of x squared is 160, so k is equal to 2, and this is going to be our answer. We have to find k, and we found it. Let's go to part b. 1. Find the first three terms in the expansion of 1 plus 3x whole to the power of 6 in ascending powers of x. Simplify the coefficient of each term. Well, for this one, the binomial theorem once again will be extremely useful. So we want in ascending powers of x. So we have to have a constant term plus something, let's say a x to the power of 1 plus b x to the power of 2. These are the first three powers, the first three terms. So in this case, a is the constant and b is the one with x in the binomial. Therefore, the first three terms, which is a to the power of n, and then this one, and then this one, will be the first three terms which we want, the ascending powers of x. So a is equal to 1, b is equal to 3x, and n is equal to 6. That means the first term will be a to the power of n. The first term, or the constant term, is going to be equal to 1 to the power of 6, which is 1. Now the second term, which is degree 1, is going to be equal to n choose 1, which is 6 choose 1, times a to the power of n minus 1, which is 1 to the power of 5, times b, which is 3x. Now 6 choose 1 is just 6, and we multiply it by 3x because 1 to the power of 5 is 1. So 6 times 3x is 18x. So we have the first two terms. Now the third term is going to be degree 2. That's going to be equal to 6 choose 2 times 1 to the power of 4. That's n minus 2 or 6 minus 2. That's 4. And multiplied by 3x the whole squared. And that's going to be equal to 6 choose 2 is going to be 6 factorial divided by 4 factorial times 2 factorial. That's 6 times 5 by 2 times 1. That's simply 15. So 15 times 3x the whole squared. 3x the whole squared is 9x squared. Of course, this is 1. This won't change anything. 15 times 9 is equal to 135. So the coefficient will be 135. So the term is 135x squared. So well, we found the three terms separately, but at the end we have to add the two terms. So all the three terms together will become 1 plus 18x plus 135x squared will be our answer. Let's go to part B2. When the expansion of 1 plus 3x the whole to the power of 6 times a plus x the whole square is written as ascending powers of x, the first three terms are 4 plus 68x plus bx squared, where a and b are constants. Find the value of a and the value of b. So the first three terms will depend on the first three terms of this and the three terms formed by this. So a plus x the whole square is obvious, a squared plus 2ax plus x squared. So the first three terms depends on these first three terms you found in the previous question. Over here, 1 plus 18x plus 135x squared. So 1 plus 18x plus 135x squared times a squared plus 2ax plus x squared. So we only need to multiply those, which give us a degree of term which is 2 or less, which means the power of x has to be 2 or less. So 1 times either of these will give 2 or less. So first let's multiply the terms which give a constant term or degree 0, so a squared. Now let's multiply those which give us a degree of 1. 1 times 2ax is 2ax, and 18x times a squared is 18a squared x. Of course, I'm writing the coefficient first before writing x. And then we multiply those which give us an x squared term or degree 2. So 1 times x squared, which is x squared, plus 18x times 2ax, which is 36ax squared, plus the last one, which is 135x squared times a squared, 135a squared x squared. And then the other terms are irrelevant since we don't need anything above the power of 2. So the first three terms will be a squared plus 2a plus 18a squared times x plus 1 plus 36a plus 135a squared times x squared. I've just factorized this x squared out of the three terms here and made that. Factorized x out of the two terms here and made this. And this is going to be equal to 4 plus 68x plus bx squared. First things first, let's equate the constant terms, a squared and 4. So a squared is equal to 4 and a is equal to plus or minus 2. Which one do we choose, plus or minus 2? We'll decide in the second one, which is equating the x terms. So we equate these. And we can write the coefficients as equal. So 18a squared plus 2a is equal to 68. So let's just substitute a equals 2 and a equals minus 2, and we need to see which one's correct. So let a equal 2. That means 18 times 2 squared plus 2 times 2 is equal to 72 plus 4, which is 76. And that's not equal to 68, so we don't choose a equals 2. Now we can let a is equal to minus 2. That means 18 times minus 2 squared plus 2 times minus 2, which is 72 minus 4, 68. This works. And therefore, a is equal to minus 2 is the correct answer. Let me just make some space. A equals minus 2 is correct. And now we can find the b value by equating these coefficients here. So b is equal to 1 plus 36a plus 135a squared. Now that's going to be 1 plus 36 times minus 2 plus 135 times minus 2 squared. That's 1 minus 72 plus 540. And when you do the math correctly, you will get 469 as the b value. And that'll be our answer. A equals minus 2 and b equals 469. Let's go to question 11. Question 11. In this question, all lengths are in centimeters. The diagram shows a cone of base radius x, height y, and sloping edge root of x squared plus y squared due to Pythagoras theorem. The volume is 10 pi centimeters cubed. A. Show that the curved surface area S of the cone is given by S equals pi root of x to the power 6 plus 900 by x. Firstly, we know that the volume is 10 pi centimeters cubed, and the volume is 1 by 3 pi r squared h. That's 10 pi. We know that the radius is x and the height is y. So 1 by 3 pi x squared y is equal to 10 pi. That means x squared y is equal to 30 and y equals 30 by x squared. Why am I writing y in terms of x? That's because we can see that the curved surface area is given in terms of only x. So you want to get rid of the y term when we calculate the curved surface area, which I will do now. The curved surface area is pi rl. That's equal to pi times the radius, which is x, times the square root of x squared plus y squared, which is the slope length. Well, we know that y is 30 by x squared. So that's just going to be pi x square root of x squared plus 30 by x squared, the whole squared. That's pi x times the square root of x squared plus 900 by x to the power of 4. Well, but how do we bring this into what we need to bring into? S is equal to pi root x to the power 6 plus 900 divided by x. Well, we can multiply the whole thing by x squared, which is pi x times x squared, which is the square root of x to the power 4, times the square root of x squared plus 900 by x to the power 4, and divided by x squared. So this and this supposed to be cancelled, but over here we have just added them, and I'll tell you why. Now we can combine the square roots, so that will be pi x times the square root of x to the power 4 times x squared, which is x to the power 6, plus x to the power 4 times 900 by x to the power 4, which is 900, and divide by x squared. Now, one of the x and one of the x squared will cancel out, so we'll get pi root of x to the power 6 plus 900 by x. That's the curved surface area, proven. That's what you're supposed to get, that's the answer. Let's go to part B. Given that x can vary and that s has a minimum value, find the value of x for which s is a minimum. Well, in order to find the answer for this, we need to take some derivatives. So if s has a minimum value, that means the derivative of s has to be equal to 0. So if you write down d by dx of pi root x to the power 6 plus 900 divided by x, we need to use the quotient rule for this. But first we need to find a derivative of root of x to the power 6 plus 900. So if you find the derivative of this is the same thing as the square root if we add power 1/2. So that'll be, using the chain rule, half times x to the power 6 plus 900 to the power of minus half times the derivative of the inside function, which is 6x to the power 5. So the derivative of the outside is the derivative of some function f of x to the power of half, which is this. And then the derivative of the inside function is just the derivative of f of x. In this case, x to the power of 6 plus 900 is f of x, and therefore we get this, which is 1 by 2 root of x to the power of 6 plus 900 times 6x to the power of 5, so we write it like this. And this is our derivative for x to the power of 6 plus 900. Now we need to find the derivative of the whole function here. So using the quotient rule. The quotient rule states derivative of function p by q, where p and q are functions of x. So if we take the derivative of this, it'll become q times p prime minus p times q prime. So q times the derivative of p minus p times the derivative of q. So if we do this for our function, this one here will become x times the derivative of p, which is multiplied by pi and then multiply by this over here, times 6x to the power of 5 by 2 root of x to the power of 6 plus 900 minus p, which is this function, times q prime, which is just pi root of x to the power of 6 plus 900, because the derivative of x is simply 1. And this value has to be equal to 0. Well, you can cancel this 2 and this 6, which becomes a 3 now. And then you can bring this pi root x to the power of 6 plus 900 to the other side. So pi root of x to the power of 6 plus 900 is equal to 3 pi x to the power of 6, which is the numerator here, divided by root of x to the power of 6 plus 900. So when you bring this to this side, when you multiply these two, we just get x to the power of 6 plus 900, and we divide here, we'll get x to the power of 6 plus 900 is equal to 3x to the power of 6. This means that 2x to the power of 6 is 900, x to the power of 6 is 450, and therefore we have found the answer as x is equal to the 6th root of 450. Now we just use our calculator to get the value of x. So 450 to the 6th root, 2.77 centimeters to 3 significant figures. You do not really need to write centimeters, just writing the value is good enough. Let's go to question 12. The diagram shows part of the curve y equals 9 minus x times x minus 3, and the line y equals k minus 3, where k is greater than 3. The line through the maximum point of the curve, parallel to the y-axis, meets the x-axis at A, which is this line here, this point. The curve meets the x-axis at B, and the line y equals k minus 3 meets the curve at point C, which is k, k minus 3. Find the area of the shaded region. Well, firstly, we can see that the point B is the point on the right compared to the other point where the curve intersects the x-axis. So this point has to have a greater value of x. And the two solutions to this equation when y is equal to 0, that is x equals 9 and x equals 3. So the point B has x value equal 9. So B is 9, 0. Now how do we find A? Of course, we know that this line here contains the x value of A, and the x value of A is the same as the x value of this turning point. And the y value of A is just 0 because it lies on the x-axis. So this line here is x equals the x value of A. This is the line. And that's also the x value of the turning point, so we can find the turning point of the graph. To find the turning point, we first write the equation of this curve expanded. So minus x squared plus 12x minus 27. Now to find the turning point, we said dy by dx is equal to 0 to find turning point. So that means dy by dx, we can find that as minus 2x plus 12 is equal to 0. Therefore, x is equal to 6 when you solve this equation. So this becomes x equals 6. And therefore, the point A is 6, 0. Now we need to find the point C. Well, we know that this point k comma k minus 3 lies on the curve because this is a point on the curve as we can see in the graph, and therefore we can substitute the x and y values into the equation of the graph. So k minus 3 equals 9 minus k times k minus 3. Now we can just divide both sides by k minus 3, so 1 is equal to 9 minus k, and k equals 9 minus 1, which is equal to 8. Well, now how do you find this area here? There's one nice trick. We can divide this into two things. One is a rectangle and one is another shape. This is not a triangle, by the way. This is slightly curved here, so you can't just use a triangle area. But you can take an integral from x equals 8 to x equals 9 because k equals 8 and then the x value of b is 9. So the area of the shaded region will be this height because k minus 3 is the y value, so it's 0 here to 5, so this is 5 units. And then this over here, this length, so a's x value is 6 and this x value is 8. So this is 2 units since it's 6, 8 here. So the total area, shaded area, will be 5 times 2, which is the area of the rectangle, plus the integral from x equals 8 to 9 of this function f of x, or this function 9 minus x times x minus 3 dx. So let's go to the next page and solve this. That's 10 plus, we can use the fundamental theorem of calculus part 2, but first we have to expand these brackets. So minus x squared plus 12x minus 27 once again dx, and this is 10 plus, when we take the integral of this term, it'll be minus 1 by 3 x cubed plus 6x squared minus 27x, whole thing from the values of 8 to 9. So using fundamental theorem of calculus part 2, this will become, when we substitute 9 in here, so 0, which is when x equals 9, we substitute, we get 0, and then subtract with whatever we get when x equals 8. When we substitute 8 here, negative 8 by 3, but because we're subtracting, it'll become positive, so it'll be 10 plus 8 by 3, which is 12 2 by 3 centimeters squared. And this is our final answer. And with this, I come to the end of the video. Please like this video, subscribe to our channel, share this video with your friends and family, and comment on how you think this video was. With that, it's me, Sanjay Vasu, signing out. Thank you. Bye.